Today we're looking at the basic concepts of the atomic structure. Now, most of you already know that the atom is made up of a nucleus. Now, inside of this nucleus, we get protons as well as neutrons. Now, these protons will have a positive charge, whereas my neutrons do not have a charge at all, meaning that they're neither negative nor positive. Now, surrounding my nucleus is my different orbitals. Now, these orbitals contain electrons that are scattered around the nucleus. These electrons are negatively charged. Now, if we look at the mass of these subatomic particles, protons and neutrons will have a mass of 1 atomic mass unit. But neutrons are slightly heavier than a proton, but not enough to be significant. Now, our electrons are very small and has a very small mass, only having a mass of 1/1836 of an atomic mass unit. Now, most of the space around my atom is empty space, meaning that the majority of my mass and density comes from my nucleus. Now, if we had to set up an electric field with a positive plate and a negative plate, and we let protons, neutrons, and electrons travel at the same velocity through the electric field, they will behave differently due to differences in their charge and mass. Now, if we look at neutrons firstly, they will pass through without deflection. So this confirms that neutrons are neutral. They have no charge and will be unaffected by the electric field. If we shoot electrons through this electric field, they will be deflected strongly towards the positive plate. So they will move towards the positive plate very quickly. So this shows that electrons are negatively charged, firstly because they are attracted to the positive plate and they're repelled by the negative plate. Now, this large deflection, the fact that it quickly moves towards the positive plate, indicates that electrons have a very small mass. Not a lot of force is needed to move them. Now, lastly, we have our beam of protons. Now, the protons are deflected slightly towards the negative plate, so they move slower towards the negative plate. So this confirms that the protons carry a positive charge as they are attracted to the negative plate and repelled by the positive plate. Because of their big mass, there's a smaller deflection. This is because more force is needed to move or attract particles. Now let's look at the periodic table of the elements. Let's take helium for example. Now this periodic table shows my element as X. A will be my mass number. This is the number of protons and neutrons in my atom. Now this can also be called nucleons. So it's the amount of nucleons in my nucleus. This is why it's also called the nucleon number. Then we have our atomic number, here indicated as Z. Now the atomic number indicates the amount of protons in my nucleus. This is why it can also be called the proton number. Now, if we would like to calculate the number of protons, this we can just write it down as the atomic number or the proton number. If I want to calculate the number of electrons, if it's a neutral substance, the number of electrons will be equal to the number of protons. Now, one that's a little bit more complicated is the number of neutrons. To work out this, we need to take our mass number and then minus our atomic number from this. So we're going to take the number of protons and neutrons and then minus the amount of protons to get our number of neutrons. Let's look at an example. Helium. Helium has a mass number of 4. and a proton or atomic number of 2. So if I would like to work out the number of protons, I can just write it down as the atomic number, which is 2. The number of electrons, I can see that my helium is neutral, so it will have the same amount of electrons as protons, so it will also be 2. Now my number of neutrons, I would take my mass number, which is 4, minus my atomic number, which is 2, and then get my answer as 2 neutrons. Now in this example, I showed the mass number as being below the atomic number. This is not always the case. I like remembering which one's the mass number and which one's the atomic number by just looking at the size of it. The bigger number will always be the mass number because it will be protons plus neutrons, where the atomic number is only protons, so it will always be smaller. Now for Cambridge, we need to switch this around, so this periodic table is wrong according to Cambridge. So for Cambridge, my mass number needs to be at the top and my atomic number needs to be at the bottom. So this was all for neutral atoms, meaning that they do not have any charges. Let's have a look at ions. Now ions can be either positively charged or negatively charged. If I look at group 1, they will tend to become 1 plus charged. Group 2 will become 2 plus charged. Group 3, 3 plus. Group 4 is a funny one. It will become 4 either positively or negatively charged. Then we have group 5, which is 3 minus charge. Group 6, which is 2 minus. Group 7, which is 1 minus. And group 8, which will not have a charge. And this is because they are noble gases and will not bond with any other atoms. They already have a full outer shell of electrons. Then lastly, we have our transition elements, and they have a variable charge, so they can form different ions and bond with different atoms to form different charges. Now let's have a look at an example. Let's take oxygen. Now oxygen will tend to become 2 negative, so it will have a mass number of 16, an atomic number of 8, and a charge of 2 minus. Now to work out the protons, I'm going to use my atomic number 8. So my protons are 8. To work out the amount of neutrons, I would take my nucleon number or my mass number and then minus my atomic number from it. This would give me 8 as well. Now here comes the tricky part, my electrons. Now because oxygen has a charge of 2 minus, it means it gained 2 electrons. So I would take the number of protons, which was 8, plus the 2 electrons that it gained to get a total of 10 electrons for this ion. So we need to remember, if it's a negative charge, it means that it gained electrons. So it got some extra electrons. If it has a positive charge, it means that it lost electrons. So it will have less electrons than the neutral atom. The last one that we'll have a look at that's also a bit different are isotopes. So isotopes have the same number of protons as well as the same number of electrons, but they have different number of neutrons. So if we take carbon as an example, the carbon on our periodic table, which is technically an average for all the carbon isotopes out there, has a proton number of 6 and a mass number of 12. But if we look at one of carbon's isotopes, it will also have an atomic number or proton number of 6, but it will have a different mass number. In this case, it has a mass number of 14. This shows that carbon 12 will have 6 neutrons, whereas carbon 14 will have 8 neutrons. So it will have different neutrons. So remember, if my atoms have different amounts of electrons, it means that they are ions of each other. If they have different amounts of neutrons, then they are isotopes of each other. Now, an element cannot have different amounts of protons because the protons identify my element. So if there's different amounts of protons, it means that they are totally different elements on the periodic table. Okay, so now that we have the basic structure, let's look at how the atomic radius can differ. Now we know that the radius is usually the distance between the center of a circle and the outside. But if we look at the atom, it's quite difficult to measure this as the electrons are difficult to define. So to measure from the center or the nucleus to the outside electron is very difficult. So what we do is we bond the atoms together to form a covalent bond. We then measure the distance between the two nuclei and divide it by 2, and this will give us our atomic radius, also called a covalent radius. Now what about noble gases? Noble gases cannot form covalent bonds because they are stable. They already have all their outer shell electrons, so they won't bond with the same atom. So what they do with this is they compress the noble gases and cool down the noble gases into a liquid or solid form. This means that the atoms of the noble gas will be very close together, almost like being bonded, but not quite. They then measure the distance between the one nucleus and the other nucleus of the noble gas and divide it by 2 to get the radius. Now this is called the van der Waals radius. The van der Waals radius is slightly bigger than the covalent radius because it's not technically bonded, just very close to each other. So it won't be as accurate, but it's the best we can do. Now atomic radius differ across the periodic table, but a definite trend can be seen. If we move across my periodic table, from hydrogen to helium across the groups, my atomic radius will decrease. And if I move down the periodic table, so down the periods from 1 to 7, my atomic radius will increase, meaning that overall atomic radius increases from the right top corner to the bottom left corner. Now this can all be explained through the use of the electron shell theory. So we know that our atomic number increases as we move from left to right across our groups. Now as we do this, our positive charge of our atom increases. This is because protons are added to the atom. But just as protons are added, electrons are also added to keep it a neutral atom. But these electrons are added to the outer shell. So no new shells are formed, only the shells that already exist. So to imagine this, we have our nucleus that will be more positively charged as it gains more protons. And we have our electron shells being more negatively charged because of the added electrons. But remember, these electrons are added to the same shell. Now, because of the great difference between positive charges and negative charges, there will be a greater electrostatic force of attraction, meaning that my nucleus will pull my electrons closer to itself and thus decrease the atomic radius. Now we also know that as we move down the periodic table, down my periods, my atomic radius increases. Now this is because as I move down my periods, each time I add an extra shell. Now these shells have electrons in them. Now the electrons that are in the inner shells will repel the electrons in the outer shells because they have the same charge. So how we can imagine this is if we're in period 2, meaning that there's 2 shells, and then we move down to period 3, thus adding a shell. This shell will have new outer electrons. The inner electrons will shield the outer electrons, meaning that they stop some of the electrostatic force that the nucleus uses to attract the electrons from the outer electrons. So this electron shielding will decrease the electrostatic force of attraction between the positively charged nucleus and the negatively charged electrons in the outer shell, meaning that there's less attraction and the atomic radius will increase. Now this is all the atomic radius for neutral atoms. So let's look at how the atomic radius will look for ionic atoms. Now this is called the ionic radius, and it's measured in the same way as the atomic radius. So they also bond two ions together and then measure the distance between the two nuclei and divide it by 2. Now we know that we have positive ions and negative ions. My positive ions will lose electrons, causing it to be positively charged. Now because they lose electrons, they will have less electrons that's further away from the nucleus. This means that there will be a greater force of attraction between the nucleus and the electrons that are left. This will decrease the ionic radius. Now my negative ions will gain electrons to become negatively charged. This means that more electrons will be further away from the nucleus and less force of attraction will occur. This will increase the radius. So as an example, if we look at lithium moving to beryllium, so moving from a positive charge to a 2+ charge, my atomic radius will decrease. But if I move from fluorine, which is negatively charged, to oxygen, which is 2- charged, my ionic radius will increase. Lastly, we'll have a look at chemical and physical characteristics of elements. Now, chemical characteristics are determined by the electronic configuration, so the way my electrons are situated around my nucleus. This determines the reactivity as well as the pH. Now, different atoms have different electronic configurations, meaning that they will have different chemical properties. My ions also have different electron configurations, so they will also have different chemical properties. But if I think about my isotopes, they have the same amount of electrons, so they will have the same chemical properties. If I look at physical properties, these are determined by the atomic structure, especially my neutrons. Now these are like density, color, phase changes like from liquid to solid and gas to liquid. Also my hardness, my magnetism, my conductivity and solubility, as well as the different states like solid, liquid and gas. Now these can be different between different elements, but they are also different between different isotopes of the same element.